Hello, cherished viewers out there. I welcome you to our first lesson on plane geometry 2, that is specifically circle theorem. And we are actually going to discuss illustrative examples on theorem 1. So without wasting much time, we'll actually discuss the two examples that I laid to you about on our initial discussion on circle theorem. So I'll urge you guys to take your seat and follow my duly discussion or deliberations on these two separate examples, and we'll get to understand how we can really extensively manipulate this theorem 1 on answering our illustrative examples. So prior to our commencement, I'll urge you guys to take 1 minute of your time to actually subscribe to my YouTube channel, that is Rediscover Your Touch, and then you also share and like my videos so that we'll all be helping one another in the latter. Okay, so without wasting much time, I trust we can commence on our workouts. All right. Okay, so tackling example 1. We are having an angle at our center. That means the value has been illustrated. So we have angle ACB becoming 60. So I will say angle ACB is 70 degrees. And we are being asked to find angle AOB, which is also our x degrees, right? So per the statement or per our theorem 1, it states that whichever angle that is being formed at the center is twice whatever is formed at the circumference, right? So in other words, in order to get our x, it means you are going to have a multiplication of our angle formed at the center, that is precisely 70, and we are going to have it twice, right? So to answer that, we are actually going to have our solution to be x degrees is equal to 2 times 70 degrees. Per our rule, x degrees, that's the angle formed at the center, or angle AOB, should be twice that of what? Angle ACB, or angle 70. That is the angle formed at the circumference. So we are actually going to have, therefore, our x degrees to be 140 degrees. 140 degrees. So in the aspect of answering this question, we'll actually have 140 degrees. So if you can't really apprehend the instance whereby the questions are being illustrated on arcs, that is arc AB, okay? Like I stated in my addendum, I stated that you can really create a short dash or dashes to create a chord or an imaginary chord. So using this chord, I trust you can really relate it to the theorem, tackling just the aspect of chord only, and that will also give you similar results. And in that sense, we'll likely have our x degrees to be twice the angle formed at the circumference per the theorem 1. So moving on to example 2, like I stated, doing the magic, we can actually create a chord, right? So I trust that one will really help us all. So let's create a chord. So we have the imaginary short dashes giving us a chord. Alright, but this time around, we are quite having example 2 to be the opposite of example 1. Why? In our example 1, the angle was formed at the circumference, and we were tasked with finding the angle at the center. And in that instance, we were tasked to multiply whichever angle was formed at the circumference of the circle to have our answer at the center. But here we are being given the answer at the center and we are tasked with finding the angle at the circumference. Like I stated earlier on, this is the opposite of example 1. So we are not going to use similar method as we used in example 1 on the same theorem. So we are actually going to have whichever angle has been formed at the center is actually going to be divided. So since we multiplied in our first example, we are going to have the opposite of multiplication, which is division. So we are going to have angle, so C, angle AOB is actually our angle 120 degrees, right? And we are being tasked to find angle ACB, which is the same as y degrees, which is the same as what? Y degrees. So we are going to have our solution to be twice of y. So 2y is equal to 120 degrees. And in that sense, we are actually going to get rid of the coefficient of y and it will actually translate to the other aspect of the equation. So we have 2 cancels 2 and 2 goes into itself once. It goes into 12 6 times. So we are going to have our y to be 60 degrees. So therefore, our y degrees is what? 60 degrees. And I trust we can illustrate it here to be 60 degrees. So you see, we've deliberated on theorem 1 and we are having separate instances on the same theorem 1. That is whereby in our first example, the angle has been presented at the circumference of the circle and we're tasked with finding the resulted angle at the center of that same circle. But in the instances with example 2, our angle was prescribed or depicted at the center of the circle and we were tasked with finding the angle at the circumference of the circle. So you realize that per the theorem, we are either going to divide or multiply. So wrapping up, I would say to you guys out there that when the angle is being presented at the circumference and we are being charged with finding the angle at the center, we have no other option than to multiply per the rule or per the theorem 1. And conversely, when the angle is being presented at the center and we are being charged with finding the angle at the circumference, then it means we are really going to do quite opposite of multiplying. That is what? Dividing the angle at the center to get the angle at the circumference in order to be in line with the theorem 1. Alright, so I trust you guys really apprehend my deliberations on these two contrasting examples under theorem 1 of circle theorem. Like I promise you guys, I'll actually be taking further examples and further theorems on plane geometry 2. And in my next video, I'm really going to tackle theorem 2 and then I'll present out its rule as well as its corresponding illustrative examples. And I trust in due time we'll cover as much as possible throughout your exams that you'll be having in your individual schools. And before I draw the curtains on our today's lesson, I'll actually once again remind you guys to take a minute of your time to subscribe to my channel, that is Rediscover Your Touch, and also to like my videos and share among your colleagues as well who might be in need of this knowledge. Help your colleagues to also make it out there, and together we could all achieve our aspirations. Kudos to you all, and I say bye.